Hello dear students, this video is to answer the question how a revolved feature can be created in AutoCAD. Well, to answer the question, I'm going to use this model in the example. Well, at present there is a rectangular prism. It is one of the features of the object. The other feature will be a ring just at this side surface with a circular cross section, and the other feature gonna be at the top of the rectangular prism. It is going to be on this surface. Okay, well, the object indent gonna be the one consisting of three features: rectangular prismatic base, a ring at its profile side, and another revolved feature at its top side. Okay, well, creating the revolved features, since I'm going to use some construction lines, and I know that construction lines are used, but after creating the model of the object or model of the feature, depending on the case, it is a good practice to take the visibility of the content of construction layer. Construction lines, keeping construction lines in the screen is a poor practice. So, to be able to filter the construction lines from the screen, I'm going to create a new layer. You know, layer means transparent paper, and have the construction lines in that layer. You know, to be able to create a new layer, first, layer managing dialog box is to be invoked to the screen. Move the cursor to layers panel. By the way, at present, see how many layers I have in the structure of this file. Clicked on this listing arrow and drop the list of the names of the existing layers. Zero layer, and one more layer. I named that layer saying solid model. Well, in this layer, gonna have the solid model of the object. Well, at present, the rectangular prism is in this layer. Okay, test it. Turn the lamp off this layer, and then see that the box will disappear from the screen. Yes, this means that model is within this layer. Turn the lights on. You know, AutoCAD uses this analogy to be able to take the visibility of the content of a certain layer. The thing to do is that bring the cursor onto the lamp symbol and toggle it off. To be able to make the content of such a layer as visible in the screen. Okay, well, similarly, bring the cursor onto the lamp symbol. Its color is not yellowish. This means the lights are off. Bringing the cursor onto the lamp symbol and making a click on it, turn the lights on. Yes, you know this. Okay, now I'm going to create a new layer in which I'm going to keep the construction lines. And then, after finishing the model creation stage, I'm going to take the visibility of construction layer. Okay. To create a new layer, you know, this is the facility. Bring the cursor onto the top left corner of the layers panel, and over there find the button and click Mechanical Layer Manager. Here is the managing dialog box. To be able to create a new layer, well, this is the wizard at the top corner along the status bar of the dialog box. The first button from the left is the new layer creation wizard. Clicked on it and then have a new row. Each row in this dialog corresponds to the layers. The name of the new layer, since I'm going to use this layer for creating and keeping the construction lines, write the name of the layer saying construction. Okay. Construction lines, I'm going to use red color for the construction lines. So to be able to select the color, clicked on the color box. Yes, along the row. It corresponds to the new layer. And then from the color selection path, select the color. I'm going to use red color. Okay, in drawing, creating the construction lines. Select and then say OK. Line type continuous. Line thickness, well, 0.2 is the recommended line thickness for construction lines. And then clicked on apply, clicked on OK. Yes, here in the list of the names of the layers, there is one more construction layer. Okay. And then okay, select construction layer. First or later, the order is not so important, but for my convenience, I'm going to have the origin of the coordinate frame about this corner point and direct the x-axis, direct the y-axis such a manner that xy plane gonna coincide with this surface, and on the surface I'm going to draw the necessary construction lines. One of them going to be axis of revolving, the other one is the profile. Okay. I like to use this facility to bring a coordinate frame to a certain specified location, 3-point facility. Clicked and then, well, indicate this corner of the surface of the prism as well as the location for the origin. Click and then indicate this corner. Thanks to snap facility, this button is on, and you see for endpoints there is an allowance. Corner point is an endpoint. Okay, can indicate such a characteristic point. Well, I indicated this characteristic point to say that x-axis extends in this direction to its positive sense, positive part, and then move the cursor to the vicinity of this corner, and it is another characteristic point. It can be indicated thanks to snap enabling, snap facility, indicated as a point along which y-axis passes to its positive side. Okay, and then, well, sure that xy plane is now coinciding with that surface. To see that it is true, clicked on grid button and ask the visibility of the grid lines, and then rotate. You see the grid lines just over the sketch plane, xy plane, and xy plane you see is coincided with the selected surface, with the surface of the prism. Okay, and then press escape button and toggle off grid invoking button. Okay. And then, well, construction layer. Yes, the active layer is construction layer. I'm going to create a line. In this example, it will extend from the midpoint of this boundary of the surface to the midpoint of the opposite side boundary. Okay, start line drawing process, and then, well, indicate this midpoint, indicate the midpoint of the opposite side. Well, this line is, in my consideration, is the axis of revolving. About this line, I'm going to revolve the profile. Where is the profile? The cross section of the ring, my purpose right now is to create a ring as a revolved feature, okay, is circular. Since it is circular, well, start circle creation process. From this list, I'm going to select diameter option. System asking the center point. First point is always uses xy values relative to the origin of the coordinate system. Relative to the origin of the coordinate system, say that the center of the ring, let's say 200 millimeters away from the origin in the x direction. So write 200, clicked on comma key, okay. Well, 300 millimeters away along the y-axis. Well, both of the coordinates are positive relative to origin, so write 300s, okay, press enter. Here is the center point, okay. And then diameter of the circle, say that is 30. Press enter. Yes. And then change the layer to solid model. Drop the list of the names of the layers, and then to be able to select a say a layer, make a click on its title. Now solid model layer is the selected one. Apply revolve process. From this list, select revolve option, okay, and then indicate the circle to say that the area region bounded by the circle is the region, is the profile. Press enter. And system asking where is the axis of revolving. Indicating 2 points along the axis of revolving can teach to the software that it is the axis. Well, snap this terminal point, snap the other terminal point. I said that it is the axis of revolving. And then how many degrees? In the simulation you see the ring just ready to be created. Okay. Write the angle of revolving. Yes, to be able to have the ring just extending from profile to profile, from this surface to the same surface, from the profile to the surface. Well, write the angle, revolving angle, as 180 degrees. Okay. Yes, managed to create this ring. Well, the ring, yes, although it is in the same layer, but in AutoCAD, a newly created one will be at the stage as an independent object. Well, now this ring is an component, and this prism is another component. But I know that these are not different components in this example. The entities of the same object. So I'm going to apply a addition process. Clicked on this button and then say that this rectangular prism and this ring, indicate both of them, and then press enter, are the entities of the same object. Yes, now it is okay. The object right now has two entities, rectangular prism and such a circular ring. Okay. And then in the construction layer, I'm going to create a plane. Why? Because the second revolve feature, well, in this example, to its symmetric cross section is at the symmetry cross section of the rectangular prism. In other words, this plane of symmetry of the rectangular prism and the plane of symmetry of the second revolve feature just coinciding. In other words, their symmetric cross sections are in the same plane. In this example, it is so. It is the characteristic property of the second revolved feature. You see, at present, there is no plane to draw the profile at the symmetric cross section of this rectangular prism. So it must be created. Well, in this example, since the plane of symmetry of the box and the plane of symmetry of the revolved feature, which is the feature to be created, just are in the same plane, they are coinciding. Well, in construction layer, well, select construction layer. I'm going to create a line, okay, extending from the midpoint of the top side boundary of the top side surface to its opposite boundary midpoint. Well, to be able to create the line over the surface, I'm going to coincide XY plane, okay, of the coordinate system with the top side surface of this prism. So start the coordinate system moving process, clicking on this button, and then indicate this corner of the top side surface as the origin, indicate this point as the abscissa, as a point along the abscissa axis at its positive side, and indicate this corner as a point well through which y-axis passes to its positive side. So, well, I am sure XY plane is now coinciding with the top side surface. And then start line drawing process. Okay, in this example, the line to have, it is needed for creating a work plane. Just to it is one of the boundary extending from this midpoint, click, to the midpoint of the opposite edge of the surface. Okay. And then apply extrusion process. Why? To be able to have a work plane at the symmetric cross section. I'm going to indicate this construction line as the boundary of the surface. To be able to create not a model, 3D model, but a surface, well, use the surface creation tools. Okay, I selected surface tab and then, well, clicked on extrude button. I'm going to apply extrusion process for creating the necessary plane, work plane. Started the process. Now system asking me where is the line to create the surface. Okay, here is the line, indicate this line, and then press enter, and then in this direction create the surface, create the work plane. The size of work plane is not so important because this work plane is needed to coincide XY plane of the coordinate system for having the XY sketch plane at the correct place. So, well, height of this surface is not so important. It may be even infinitesimally small. I'm going to create it in this size, say that 700. Okay. And then over this surface I'm going to draw the necessary profile and also the necessary axis of revolving. Okay. For that purpose, I'm going to select construction layer again. Yes. For my convenience, I'm going to coincide XY plane with this work plane. Okay. Start the moving process and then say that this is the origin and x-axis extending in this direction indicated this terminal point as one of the point of the x-axis. Okay, through this point x-axis to its positive side passes, and then this corner point is a point through which y-axis passes. You see, I'm indicating the characteristic points using snap facility to be able to precisely coincide XY plane with such a work plane. Okay. And then, to be able to much more easily see what I am drawing in at the sketching stage, I'm going to change the visualization style from conceptual to wireframe. Okay, and well, I don't want to see this say ISO lines. I'm going to take their visibilities away. How? Visualize, tap, and then here clicked on this listing arrow and then select facet edges, not ISO lines but facet edges. Now I can see the boundary of the surface, not the ISO lines. Okay. And then in this example, the axis of revolving will be the one extending from midpoint of the boundary of this work plane to its opposite side midpoint. So start line drawing process. Okay, piece of straight line, and then indicate this point as the terminal point of the line and indicate that midpoint as the other point. Okay, I'm going to use this line as the axis of revolving. Okay. For having the region, the necessary profile, thereafter to use for creating the revolve feature, well, in this example, there will be a circle arc and straight boundaries. So I'm going to create a circle. I selected again diameter option, center point. Where is the center of the circle? Relative to this origin, abscissa value, say that is okay, 250. Clicked on comma key. Ordinate value, let's say, is 300. Press enter. Here is the center point. Diameter of the circle, say, is 300. Okay. And then start line drawing process. And then, well, in this example, it is the case. One of the straight boundaries of the profile starts from the midpoint of this circle. Okay, indicated, and create the line. I'm going to create a line. Okay, it is gonna be an inclined line. Yes, it is length, let's say 120. Clicked on tab key, inclination angle into the box, write it, say that is 50 degrees. Now, since the angle well, for this inclined line is measured in the counterclockwise direction, right angle is positive. It is important. If the line is to be created as not inclined in the up but inclined in the down direction, well, right angle as measured in the clockwise direction, how? As negative. It is important. Well, 50 degrees. No need to write degree symbol because AutoCAD knows that the number into the box after clicking on tab key is the angle of inclination. Okay, inclination angle. Press enter. Okay, and then the other line going to be, yes, a horizontal line. Its length, let's say, is 130. Okay, tab key, angle is 0. Press enter. And the other line, well, since I don't know the distance from here to this boundary of the surface, how many millimeters, I'm going to use trim technique. So have such a further extension. Have the line as further extended. Say that the length of the line is 800. Clicked on tab key and then angle. Here be careful. The angle you see from the simulated arc just to be written as measured in the clockwise direction. Right angle as negative, minus 90. Press enter. Yes. Okay. Then press escape button. Restart the line drawing process. In this example, the other boundary line to have starts from this midpoint. Okay, and it is extending in the down direction. Okay. This is just an example. In the example, that is the profile. In the end, to have the profile, these are needed. I'm going to create the line again. I don't know, since I don't know the distance and I don't want to calculate what is the distance from here to the boundary of the profile, other boundary of the profile. I'm going to use trim technique. In trim technique, you know, we create the lines with further extensions and then apply trimming process to locate their terminal points precisely at the necessary locations, places. The length of this line, let's say, is 400. Okay, angle, tab key. Don't forget the right angle as negative, minus 90. Why negative? Because from the simulated arc, I see that the angle is ready to be gathered as measured in the clockwise direction. If it is clockwise direction, measurement is in clockwise direction, right angle is negative, minus 90. Press enter. Okay, and then press escape button. I'm going to trim the further extended parts to be able to locate the terminal point of this boundary and the other boundary precisely along the boundary of the work plane. Okay, start trimming process via clicking on the trim button. And you know, in AutoCAD the trick, after starting trimming process, don't forget to press enter and then indicate this further extension, the other further extension. Yes, see where are the further extended parts. Okay, I started the trimming process. Yes, press enter and then be able to indicate the further extensions. Yes. Yes, after starting the trimming process, yes, do it again. Start a trimming process, press enter key, and then indicate this further extension, indicate that further extension, and then, well, Press escape button. To be able to have the profile as a closed profile, I'm going to create a line to join this point to that point. I forgot to trim a part of the circle, so restart the trimming process, press enter, and then indicate which one, this half of the circle. Okay, that is the profile. Okay, yes, and then define the surface bounded by the boundary lines as a region. You know, this is the facility to use. Expand drawing panel, and then clicked on region definition button, and then indicate this line as one of the boundaries, indicate that line as the other, indicate this one, indicate this, and finally that one. Press enter. Okay, and then the rest. In solid model layer, I'm going to create, I selected solid model layer, the other revolve feature. Start the revolve process, and then indicate that this is the profile. Press enter, and indicate the starting and ending points of this boundary as the axis of revolving. Okay, and the angle of revolving into the box, right, 360 in this example. Yes. Okay. Change the visualization style to conceptual, and then yes, see that revolve feature is over there. I'm going to take the work plane, the visibility of work plane from the screen. You know how. Expand, drop the list of the layers, names of the layers, and then turn the length of construction layer. Yes, that work plane will disappear from the screen. Yes, here is the object. Addition process is needed. This last created revolve feature is as if a different component. Apply addition process, clicked on this button, and then say that this revolved body and the rest are the features of the same object. Press enter. Now okay, it is a single object. No need to have the coordinate frame as connected to the model. It is a poor practice. Clicked on word coordinate button, and then shoot it from its special location to its word location. Click. Yes, the coordinate frame is at its word location. Okay, and then to be able to make this model as solid model, I'm going to assign the material. You know how. Visualization tab, material browser. Okay, it is made of, for instance, bronze satin. Okay, move it, select the material, and drag the mouse toward the object. Release the button. Okay, to be able to see the model in the realistic appearance, you know, drop this list and select shaded option. Yes, now it is in the color of bronze. Yes, in this video you saw, I think it became clear enough how revolve feature is created. The second part of this video is more interesting. To be able to have the region at the correct place. First I created a surface, a work plane, applying extrusion process using the surface creation tool, not extrusion process to create a solid model, 3D model, but extrusion process along the surface ribbon. Well, it is written extrusion. It is the facility to create work planes, to create surfaces. Well, it is this facility. I use this facility for having the necessary work plane. And in the work plane, I had the profile and then apply revolve process. That is it. Thank you for your watching.